Next up, we have even and odd functions and the property related to that. First thing is, I'll explain what is an even function. This is an even function. Whatever value you have, a respective value is across the 0. At 2.5, whatever the height is there, at minus 2.5, it's the same height. Basically, this is an absolute value, that is your magnitude, that is your modulus of x basically. Right? I'm looking at modulus of x. Those are your even function. I mean, even this is your even function. Right? So what is even function? If I happen to take a mirror along the y-axis, this line, right, along this line, this two will be reflection of each other basically. Agree? If I keep a mirror over here, the mirror will give a reflection of the right hand side that will look like the left hand side. If I happen to keep a mirror, either of the side will give the reflection of the image of the other side basically. Such a graph is called as your even graph. Now we need to know something called as odd graph also. I'll show that next. So whenever we have even graph, basically f of minus x is equal to f of x, we have the following result. Right? So we have minus a to a f of x dx, that can be split to minus a to 0 f of x dx plus 0 to a f of x dx. Now we'll take the first part, because anyway all of this particular expression is already there. We just have to change the first integral. Now to do that, we will call t as minus x. So dt is equal to minus dx. So when we substitute x is equal to minus a, the lower limit, t will be equal to plus a. And for x is equal to 0, t is equal to minus a. Right? Now wait. For x is equal to 0, then my bad, this should be minus t. No, I'm substituting it right. I'm looking at the wrong expression, my bad. Here. So this would be 0 again. I was looking at this actually. That's the original expression, right? Now, therefore, your integration will look like plus a to 0 f of minus t and minus dt. Correct? So this I can rewrite it as 0 to a using the negative. The second property, property 1 actually, this is property 0 and this is property 1. Using the first property, I can flip the integral value and the negative becomes positive. And what else can we do? We can change the variables. 0 to a f of minus x dx. But this too is equal to f of a f of x dx. Reason being f of x is equal to f of minus a is equal to f of x, because it's a even function. And finally, we have the answer to be 2 times of that. So that's your even function. Same funda for odd function. The final answer is that it would be negative. And so they'll cancel each other and you have the answer to be 0. Okay, yes. So this is case 1, that's case 2. So odd functions are, you can imagine how would they be. You already seen one actually, or you will have a basic idea by now. This is an odd function. If I keep a mirror along a line representing y is equal to minus x, we will find the following reflection. One last example. Again, if I happen to keep a mirror this way, we'll get a reflection of each other along y is equal to x, along the line y is equal to x actually. Okay, so you can have a look at all of this and copy it off. Here the example is sine of minus x, or doesn't matter, minus 10 to 10 sine of x dx. There an example is modulus of x, if not cos of x. It can be anything. I don't have space actually. Minus 4 to 4 cos of x dx. Yeah. Now you can pause and have a look.